Hi, my name is Łukasz Langa.
And my name is Pablo Galindo.
And this is the Core.py podcast, an established podcast, where we discuss internals of CPython and our adventures in making a new version of your favorite programming language.
Wow, established.
This is our 13th episode, and it's a really lucky one. We're joined today by Brandt Bucher. He is a CPython core developer working on the Faster Python team at Microsoft, and the main person behind the JIT, the just-in-time compiler inside Python 3.13. This should be a good contrast with the previous episode now that we have an adult in the room. Hi, Brandt.
Hello.
Hey, what's up?
Thanks for having me. I don't listen to podcasts, but I listen to yours religiously. I love it. And I think it's because I'm the exact target audience, right?
Right. So when Łukasz was saying that only core developers listen to our podcast, it's like you.
Yeah, no, I just listened to it. How many streams did you get on the last one? I just listened to it that many times. It was all me.
That was okay. So you were very diligent because that was our most popular episode by far.
Oh, really?
Yeah. Almost 1/3 more than any other thing. It was quite surprising. I suppose that people like weird shit.
Nice.
So you all Brandt Bucher. It was very impressive because the algorithm that duplicates IP. So I'm very glad that you bought a lot of different machines in Azure or whatever it is to make our numbers look good.
Yeah, across all the different podcasting platforms too. Yeah.
Awesome. Yeah.
It's tricky, but it's worth it in the end.
Well, but the real reason, the listeners will know the real reason you listen to us, which is just to annotate everything that we say that is wrong. So you can then in the background just tell us we made mistakes. So I think this is going to be our first question. So tell us everything that we got wrong when we talk about your work, because as you know, you have been quite mentioned in the podcast due to your very prolific list of contributions. So I'm sure we screwed up some stuff. So now is your time to tell us everything that we said wrong. And if you don't say anything, then you are officially stating that we were 100% correct. Wow.
You know what? I might actually have to admit that you're 100% correct, because off the top of my head, I don't see anything, or I don't remember anything obvious where you were talking about my work and you said something that was obviously incorrect or something like that. So
not even the pronunciation of your surname. I tried to make it correct.
I was actually waiting for Pablo to still make this joke one last time, but no, he was very professional.
Yes,
this time.
Booker. Yeah, I spent 5 minutes before, after I meet someone with a surname I struggle to pronounce. Then I go at home and I look at the mirror and say, Booker. Pronouncing surnames is very important. People identify with those.
Right, obviously. So I see in our super secret doc, I got a bit of an boring question to ask, but one that people who might not be familiar with you might actually want to know about. So let me just spin it a little bit so that's useful for me too. So I'm running EuroPython sprints this year for CPython, and very often people come to me and they're like, hey, I want to contribute to CPython. What should I work on? What should I do? So what's your story? How did you start contributing to CPython, and how did you find your first things to work on?
Yeah, some of my first open source and Python related contributions were actually not in CPython. They were in MyPy and TypeShed and sort of those adjacent projects. So I think that those were, I really enjoyed that the maintainers of those projects were so welcoming, and that I was able to sort of get up to speed with open source contribution, but in sort of a lower traffic project like that, which I thought was really interesting. And how does anyone get involved in open source, right? You either find a bug or request a feature. And so that was kind of the sorts of early contributions that I made in those projects. And it wasn't very many, but just things I noticed that a keyword argument was missing in TypeShed, or that there was some feature type ignores weren't working the way I expected them to in MyPy. My first, I forget exactly which one was my first, but one of the earliest ones that I remember in CPython itself was actually a bug that I encountered at work.
Oh.
Yeah. And so I was just working with byte array, and I was calling extend on some iterator. And I got this weird new exception that I'd never seen before, a system error.
Oh.
And so I looked it up and I was like, oh, what's a system error?
Oh, ding.
And, the docs say this is an internal bug in the CPython interpreter. Please report a bug or something like that. And I was like, oh, jackpot. This is my in. And no one had found the bug before. It had been there since forever. But basically the bug was in bytearray.extend and also I think a couple of other places. Basically, while you were iterating over elements in the iterator, it wasn't being checked for error. So basically, if an exception was raised partway through iteration, that exception would go unhandled, and we would just basically keep iterating.
So the system error that you were getting is like exception, like a function return with error set or something.
Yeah, something like that. Yeah.
A classic.
And so it was just a simple, like, adding like a pi error occurred or something to one place. But that was like the first one where it's like, wow, I like found a bug and then I fixed a bug and then it's going to ship in 3.8 or whatever. So
that was a really good release. So yeah, thanks for your fix.
that was really, really cool.
Right. One important thing: don't report every occurrence of system errors, dear listeners, as internal errors. Because if you mutate a dictionary while you are iterating over, that's a system error.
That's a system error? No, that's a runtime error. Yeah.
No, it's a runtime error. Sorry, runtime error. Yeah. Okay.
I'd like to make an amendment. So there is something wrong that you just said, which was, this podcast isn't perfect anymore.
It was just to check if you are attending, you are listening correctly. Okay. Good.
Okay. It's interesting how you found like this issue at work, and great that you got it fixed. But what happened later? Like a lot of people are just drive-by contributors in that exact way, where they find an issue in production somewhere, they want it fixed, they get it fixed, they get upset that it's going to actually be released next year when they're no longer like actually very happy about it because they need it fixed like next week. So we tell them how to build their own Python or whatever, and you never hear from them again. So you kept contributing. How did that work?
Yeah, and once I kind of decided that I really wanted to get involved in CPython development, I just sort of made it part of my morning routine. Like I knew that it was something I was going to have to like stick with, right? But I feel like a mistake that a lot of people make early on when they decide that they want to become like a contributor or maintainer of a project is it's like, okay, like let's find all the different ways that I can get code merged. And like if you look, we've got like 1,500 open PRs and 8,000 open issues and all of that. So like it's not fun, but like it helps if you recognize that the triage work is actually like it's sort of the easier path to making impactful contributions, and you actually learn a lot about the project and about the code and have kind of insight into the way that the development happens by contributing through those avenues. So I just made it part of my morning routine every day to open up the GitHub issue tracker and basically find 2 issues or PRs every morning and either review them or try to triage the issue.
I find that fascinating that you do this in the morning. I think the like most people are actually night owls like for contributing to CPython. So this is quite cool because you could totally make a video. This super fancy videos that morning routine of like software developer, and then you go with your bagel, and then you like or like morning routines or billionaires, and then contribute to CPython, right?
So let me tell you about my ironic thing. Like I am definitely a night owl, right? And I thought, perfect. Now that I moved to Poland, I'm going to be working with people in the US. So things are going to cancel out. It's going to be amazing because we're going to be contributing essentially with a large window of the same time. And you know what? A lot of those people in America are also night owls. So it doesn't help at all because they push sometimes enough where I could sometimes just wake up and still talk to Ned Dealey because he's still up so super late, like where he is. Pennsylvania. Yes, only East Pennsylvania.
And you can have kind of extreme examples too. So like Ken Jin comes to mind of where he basically keeps US East Coast hours, even though he's in Singapore.
Right.
And so when he came to the US for PyCon, he was joking that he didn't actually have jet lag because this is already like pretty close to his default time zone.
We should totally do one of these super TikTok videos, the life in a CPython contributor, and then you look at the back tracker while you are like eating cereal or something.
Yeah.
But let me jump to something totally different because like many people know you for the work on the faster CPython team and certainly now on the work on the JIT compiler. But many people maybe don't remember that you were the person that actually implemented pattern matching and contributed quite a lot to the PEP. You're one of the authors of the second round, I think, right? Because like it was an initial PEP that got splitted into many. I don't know what of those peps you end being author, but at least one or two. So how was this experience? How was contributing to the peps and the implementation?
Yeah, so I contributed to both PEP 622, which was the initial kind of giant PEP that ended up getting rewritten and split up. And then also 634, which was the specification version, or the specification PEP. So there was like a specification PEP, a tutorial PEP, and then like a rationale and justification PEP. And so the specification PEP was the one that actually got accepted. The other two, I think, were informational.
Informational.
Best kind of PEP.
Yeah, we have a bunch of jokes around informational PEPs.
Yeah. A bunch of people actually think that that was my first PEP, but it wasn't. I had already done the dictionary union operator PEP. That was a co-authored one. Zip's strict keyword argument PEP.
But did you implement is the memory failing me? Like, did you actually end implementing the dictionary union?
Yeah, that was me.
Very cool.
Oh, okay.
I just fly under the radar. Yeah, because I'm so quiet and humble.
Everybody's using that, by the way. It was
everybody's using this.
It was such a silent thing at the time, but now everybody's like, nice.
I'm glad we ended up going with the union instead of. I think the original proposal was addition, which felt a little icky.
Right.
Yeah, so dictionary union, the zip strict keyword argument, which I use all the time now. Relaxing grammar restrictions on decorators was another one. So making decorators basically be any valid expressions. That's kind of another minor thing, but you see.
Do you actually use this?
Did you use your own PEP?
Yeah.
Do I use my own feature?
Right.
Yeah. Yes, I have used it before. It's not something I'm using like every day, but there have been a handful of times where like I've been like, oh wait, yeah, I can do that now.
Well, this make James Powell extremely happy because he was used to do this weird appliance. Like, he loves this trick when you create like a function that does a computation and then you
people
put
putting like lambdas and stuff.
Yes, lambda
in there.
x equal x. It's just a call in the decorator just to like do some pre-computation and put it in the global scope in a way that is weird.
Yeah, I've never put a walrus or a lambda in there like for like an actual reason, but
right.
But do you actually remember any use case for this? Like, just to tell our listeners, like...
Yeah, I believe it was indexing. So adding like brackets and indexing into like a list or a dictionary of decorators or something like that.
Okay.
Again, I don't remember it off the top of my head, but I do remember that I have used it before.
Cool.
But again, it's not one of those things that like I use all the time. And the PEP itself says like, this isn't like a super necessary feature, but it's a very kind of low maintenance feature, and it unblocks just a couple of things that feel like they should work anyways.
Right.
Well, so how was actually implementing pattern matching?
Oh yeah, that was the real question, right?
Actually, don't escape.
So that was actually a really just fun, engaging, frustrating, but rewarding COVID project, right? Because like we're all in lockdown when the pattern matching stuff was going on. So that was kind of like what I was doing at the time. And I really enjoyed it because I got to do a really deep dive into the bytecode compiler, which actually like came in handy later when I started working on performance work as well too. But like being able to implement new syntax, and especially something that's so declarative, and basically there's a lot of work that needs to happen in the compiler in order to make it work. I've never taken a compiler's course or anything like that. And so it was like a good kind of trial by fire, I guess, to implement this thing. But I also learned a lot too about like the parser. So the PEP was actually kind of I had some experience with the old parser because of the decorator syntax change.
Right.
But this was my first experience with the new parser, and the new one is a lot nicer. Thank you, Pablo.
Awesome. I was going to ask, how did you find it? Actually, let me say something here. At some point, I was checking the how the implementation was going for some reason, and then or I was checking the history. I don't remember what it was, but I saw something very cool that I think a lot of people have not done before, which is that you made the changes. Correct me if I'm misremembering, but you made the changes in the parser quite late. And originally, you have this cool thing when you said, well, actually, even before I do the syntax in the parser and whatnot, I can just create these AST nodes. And then you have like, in your files, you have like these trees of AST nodes that you were passing to the compiler to implement the compiler changes. So you couldn't actually write match in the parser because you were figuring that out or whatever reason it was, but like you were basically starting after the parser. So you were creating this is how the AST will look like. So I will do the parser later, right? Is that correct?
Yeah, that does sound familiar. I don't remember exactly, but yeah, I do remember doing something like that where I was just feeding AST nodes directly to compile.
Right.
And so like being able to develop independently of the parser changes, because most of the parser changes were actually written by Guido because the parser was very new, and I think we also needed like soft keywords and a couple other little things to make it work correctly. And so most of the actual grammar changes were written by him. And so it was nice that those two streams could kind of happen in parallel during the earlier stages.
Yeah, we at the time, I don't think you were seeing that, but at the time we that was the moment when we added the polymorphic parser structures. So it's not just the void star casting all around, so you get compiler errors.
Yeah, I remember that merge because I had to add those like type hint annotation things everywhere. Yeah.
I mean, it sounds painful, but this saves you a lot of trouble because, like, what happened before is that, I mean, you have suffered this, I think, later with the faster CPython. If I recall, it was one of these weird frame problems.
Gosh, yeah.
Yeah, but do you remember like that sometimes the frame call object it was a set or something like that, or a dictionary, like So this used to happen in the parser quite a lot because you cast the AST node to something that is not it, because you say this is like a statement, and it's not a statement, it's an expression or whatever it is, and then it's like half because most of them share the same structure, half of it works, so it goes through it quite nicely until it doesn't, and then you get this weird like error very, very late in the game when integer 3 is not the string 4, and like that was super painful because not even Valgrind was able to find that because it was fine. It's just memory that is correct, and the structures are mostly the same. It's just that then when you try to use it, then it's like too late. So it was worth the pain of trying to fix it, because like you get now the errors at compile time. You say like, hey, you tell me that this is a expression, but it's a statement, so it's a compiler.
Yeah. But I mean, working with the new parser was like really, really nice, especially considering like the depth of the changes that needed to happen for the grammar itself.
Right.
And I really enjoyed working on the bytecode compiler too. I heard that I made Carl Mayer's life a lot more painful with all of those compiler changes, because they at Cinder, or first, I believe it's for static Python, they have a pure Python version of the bytecode compiler that they strive for 1-to-1 compatibility.
Oh.
And the pattern matching portion of the compiler is one of the kind of beefier parts of the compiler, because it's actually kind of transforming these declarative constructs into kind of subtle code in places.
Oh, yeah.
Especially when it comes to like binding names and alternate like OR patterns and guards and things like that. And so he got to re-implement all of that in pure Python. Oof. So sorry, Carl.
Well, the trick is that we already interviewed Carl, so he's not coming back until a bunch of extra episodes. So
he can't respond.
So he cannot respond.
He can start his own podcast and then like
just
complain
to answer Brad.
Just start podcast beef. Yeah.
But wait. You told us or me or someone that you wanted to do a bunch of cool optimizations on pattern matching. You told us. Is that true, Brandt? Is that true?
I did say that in a PyCon talk, yes, that I had some cool optimizations in the pipeline.
You try to seduce everyone into thinking that you will do this cool decision trees and blah 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 blah. What is that, Brandt? Because I don't think the JIT compiler is giving us that. What is that?
So since then, I actually started a new job. And
the new job excuse.
That kind of started taking up most of my contribution time. Yeah. So I do have like a bunch of kind of toy implementations of decision trees sitting on one of my laptops somewhere in pure Python. So basically the prototypes are like a pure Python version of the bytecode compiler that kind of does these more efficient transformations. So maybe someday I'll dust it off, but I was lucky enough that the stuff I was doing in my free time started becoming my paid job, and so I started doing with.
So the job you're talking about is already faster Python?
Yes.
So that's already Microsoft?
Yes.
Okay, so when you started on that, you say like, oh, my priorities changed. So what was your first priority? When you joined that team, like, was this already like, hey, somebody's got to write the JIT, like, and you pull the short
No.
straw, like you're doing it. So what was the first thing that you did?
No, so like at that point, the specializing adaptive interpreter was very new, and so there was a lot of work kind of happening on that for the 3.11 release cycle, and there were a lot of other changes going on at the same time too. So a lot of my early work for the team was like adding new specializations, fixing bugs in existing ones, also some work on frames, which I mean, I could talk for hours about all the crazy bugs that happened because of our changes to frames in 3.11. So like in 3.10 and earlier, frames are Python objects, right? And one of the optimizations in 3.11 was basically making it so that those Python objects aren't actually created unless you ask for one. Oh, yeah. So if an exception is raised or if you're tracing or something like that. And there were all sorts of crazy bugs that came out of that because, like, thankfully this isn't the case anymore, but basically for most of Python's history, when we've had the garbage collector, it's been the case that if you are allocating memory, if you're allocating a GC object, like, for example, a Python frame object, that could actually start a garbage collection.
Yes.
And so that could lead to some very weird reentrancy things where in the process of trying to create a frame object, you start a collection, and then that collection raises an exception or starts a debugger or something, and
you start a debugger.
It actually materializes that exact same frame object.
All right, because someone puts a breakpoint on a del or something.
Well, no, the actual case where it's happening is it's always PyTest with these things, because PyTest is basically like. Usually when there's a bug in frames, it's someone reporting like, oh, I've got this giant async framework and PyTest, it runs the test in a random order, and 1/10 of the time a random test will fail with a crash, or my frame turns into a set object or something like that.
Right, so just one parenthesis, sorry.
Yeah.
Did you know when people talk about UB, like undefined behavior in C++, and they say like, oh, like unicorns can appear here, right? Like, or you say like anything can happen. So man, I think you just gave me my best new favorite sentence here. Like, someone may start a debugger here, like, you know.
No, seriously, but like if you allocate an object, there could be a debugger started in there. People start debuggers in dels, like.
No, I believe you.
Just a whole tangent. I love PyTest as a library. It's one of my favorite libraries, but like the entire plugin system is
bananas.
It's implemented as a giant tangled mess of pause generators, essentially. And they do all sorts of wonky things like, for example, if a warning or an exception is raised in certain places, they'll actually stash the entire traceback for walking later for you to report. So basically, if there's like an exception raised in a del that's like unraisable, they will catch that unraisable exception, basically stash it away, which basically keeps the entire stack and everything referenced from that
in memory
for later walking. And so weird things happen when, like, in a garbage collection, under del method is called, and then you get like someone raises a warning or an exception from a del method saying, "Oh, you forgot to like free this resource" or whatever.
Right.
And so that will actually materialize the frame that started the garbage collection because that's in the stack at that point. And so now you have two of these frame objects that point to the same like underlying frame, and they're fighting over ownership. And
this thing about like about the starting, you know, like the GC running anywhere sounds very painful, Brandt. It will be very useful if someone fixes that. For instance, me, I fixed that. Wow, yes.
Paulo did fix it, and that was the nicest thing. And actually, I think you fixed it. I think it was like you fixed that in 3.12. The same week at the sprint that I fixed the frame bug.
Yes. It was because you added a test or something, and that the test, like test frame, blah blah blah. Like you try to reproduce
sneaky frame object. I think
sneaky frame object, and that test started to fail in some cases because there was some stupid edge case or whatever it is, and when like you were like, man, I hated this. Like just keep it away from me. And then we merged this change, and the test magically fixed itself. And it was magical. Wow.
So now what's happening is garbage collection only happens in the eval breaker.
In the eval breaker.
Yes. So that's a lot nicer because it happens at these well-defined points, and not just any time that an allocation happens, you can invalidate the world, basically, which is something we care a lot more about now.
This fixed so many other things. For instance, the classic one when this happened, which was very painful, even if you didn't involve frames, it was that when you are... I think we changed that slightly just to make this less likely, but when you are initializing a tuple, so you say first, I want a tuple of 4 elements, and then Python gives you 1, but for efficiency or whatever reason, it's full with nulls. And then you can start setting the items in the tuple, but then for whatever reason you create the item that you want to put there, and it's a new object, and then the GC says, time to run, and then it runs and it finds this tuple, and it's like, oh, it will be a pity if someone tries to visit this tuple without a null, and then it's bang, and it's not bueno. So yes, that was fixed. And I think it was so crazy because, man, like this is the kind of... Sorry, I should change the way I'm going to describe this because I fear controversy here on the way I was going to say
the first controversy of the day.
No controversies. No, everybody is nice. So some people were going to try to add new interfaces to solve the problem in a, let's say, non-optimal way. So you have like new tuple no GC or something like that, right? And you know, it was time for the surgical option of just fixing it.
Fixing the GC. Yeah.
Well, cool.
Yeah, just one more thing that I thought of, like early kind of changes, the things that I worked on for the faster CPython was, along with our specializations, we also cache a lot of information. And so one of the kind of bigger projects that I did was actually moving those caches in line with the bytecode itself. So basically, like if we're caching an attribute load or something, then there are actual physical like pointers and counters and versions and things like that in the bytecode stream itself. And that was a really big, fun, interesting project too, with all sorts of bugs because self-modifying code is crazy. Yeah. And there was one insane one where we were trying to do adaptive super instructions, which is like replacing multiple instructions at once with one bigger one. That basically that involves looking at several instructions and looking forward and looking backwards and all of that. And at one point, we were trying to look at the instruction prior to the current one, and we were actually reading an inline cache like it was a normal instruction, and that triggered some optimization that actually like broke the meaning of the code entirely. So we were calling one method on an object instead of a different one, but nothing like crashed. It just did the wrong thing, which was wild. And so like instead of like closing a file descriptor, we were like opening a new one, and so we were getting all these resource errors and crazy stuff.
But it wasn't an immediate crash. It was just simply like wrong behavior.
Exactly, yeah. So it was like we were basically replacing one of the inline caches with a new bytecode instruction and executing that instruction, but it didn't change the state of the program in a way that crashed. It just started doing the wrong thing, which was like a total nightmare to debug because all of our bytecode assembly tools were like skipping over inline caches, or we just ignore them when we're looking at them. And so it was crazy that it was actually being rewritten as part of the specialization process. So that was like just mind-bending.
So how did you find it, right? Because obviously, like probably what happened was you observed this invalid behavior at some point, right? And then what?
Then you suffer.
I forget exactly, but I think I was literally just like stepping through the execution of the program, and like I had narrowed it down to like one specific method, like deep in async IO. And I had basically figured out that we were supposed to be calling one method or one function in the OS module, but instead we were calling a different one. And so the crazy thing is that the arguments to the method that we were passing like were still valid, and so and so again, like the method call succeeded. It just did a different thing than we were expecting.
Wait, Brandt. Is this at the time? I remember at some point in the Faster CPython meetings, you had this whiteboard with all this async IO stack. Like you look like this, the mean person that has the whiteboard with the conspiracy theory like threads and whatnot.
That's how generators work. That's the process of sending a value into a generator. It goes through all of that tangled web of function calls.
All right.
Oh, so the Pepe Silvia thing was generators with async IO.
Yeah.
If this was a Call of Cthulhu RPG, then you will lose five points of sanity, like mental sanity by just looking at that whiteboard.
Well, generators are so much fun because, like, if you look at it, we're implementing like generators, coroutines, iterable coroutines, asynchronous generators, and I think that's it. But just so many things are all just like sharing the same code, and sometimes we're throwing exceptions in, and sometimes we're passing a value in, and sometimes we have optimization so that if we're just advancing the iterator, we take some fast path. And generators are like not one of my favorite parts of the code base. I'll just put it that way.
Right.
Okay, so all this work doesn't really look like it leads directly to the jet. So how did it happen that you ended up like working on that?
Yeah, so there was a paper floating around. I forget if it was Mark who found it or Mark Shannon or maybe someone else. But basically there was a paper floating around that described this copy and patch strategy that the JIT is based on.
Oh, I read the silly version of it, like the blog post about like, Lua JIT, but like, made automatically. And it's only 30% slower than the manual Lua JIT. So I read that article.
Yeah, I forget which came first. Yeah. But I also forget if I read the blog post or the paper first, but basically as part of our work, like we want to try to find cool new ways to speed up Python. A lot of that is like, we don't necessarily need to invent anything, right? Like there's lots of interesting research out there that we can try to apply for this programming language in particular. And so I read that and I was like, whoa, this is really cool. Like we can get into how it works in a bit, but like, when I saw it, I was like, this actually makes like so much sense and is so simple that I feel like I could just like prototype this in pure Python. And so that's actually just what I did. So I started taking some time to just see if I could get this copy and patch thing working. And so I think it took me about a month, maybe 6 weeks of just kind of like 25-50% of my time.
No. You should start measuring time in mornings, like morning routines. Yes.
It was several mornings later. Basically, I got it working in pure Python. So like we didn't have the tier 2 interpreter at the time. So like I had my own tracing implementation written using like a Python trace function using sys.monitoring. And actually compiling everything using like the mmap module and C types.
Nice.
Like basically
hell with hopes and dreams.
Yeah. So using C types and like putting a function pointer to the memory I'd allocated and actually like calling that function pointer and stuff.
Oh, nice.
It worked. And so when I got one of our benchmarks passed, so like the benchmark that I had kind of set as a goal for myself was the n-body benchmark, which basically simulates like gravitational orbit for the solar system.
Nice.
And so it's basically just a bunch of floating point addition and multiplication. So it doesn't use that much functionality of Python. It's all just kind of the loop doing math. And so it's good for like these proofs of concept.
By the way, sorry for the interruption. I just have to say this like here publicly. I'm a physicist and I have, for whatever reason, always...
Oh no, did I say something wrong?
No. You say everything...
Is that pedantic Pablo? Why are we talking to pedantic Pablo?
Pedantic Pablo. It's technically not incorrect, but I'm going to say something. So I was extremely disappointed by that fucking benchmark. Let me tell you something. Like when you... Yes. I was extremely disappointed, man. Like this venture is a fucking joke. Like, look, when you implement an n-body simulation in physics, which is something that most physicists learn when they are learning how to code, like because normally you code something that is for physics, right? So the classic like first simulation that you do is like a n-body simulation, and what you do there is not like cute, this is the sun and like 3 other like planets. No, man, you throw like 10,000 planets. And it's ON squared because, like, every planet needs to be checked against all of them. Maybe just you can remove the symmetric interactions, but very quickly you discover that that's not the technique people use. And then, you are introduced to octrees, which is this space partition algorithm. And I thought, the benchmark is certainly the ON squared version with like 10,000 like bodies or something, right? Like that's why we have it in there. No man, it's just fucking like 8 planets. What a benchmark is that? That's not benchmarking shit. Like it's just 8 planets, man. Boo.
Well, PR's welcome, Pablo. PR's welcome.
Yeah, no. I'm going to throw a real one, like with octave partitions and shit.
So,
Yeah, you will
so
see.
it's n for an n that is smaller than 9.
It's like fucking 8 planets, man. Like with
8 body, right?
the integrator is like leapfrog or something. I think. And like so, it's like it's disappointing. Really disappointing.
Well, I was proud I was able to get it to compile with the new hacky JIT that I'd created.
My point is that if you will have the real one, the 10,000 planets kind of shit, then it will fucking fly with the JIT, because like there is so many other interactions that you will have to fix with the JIT instead of just the 8 ones and then just the loop. But anyway, sorry, that Brandt Pablo out.
I you know what, I'm proud that I was able to get 8 body working. Like I said, I embarrassed myself in Phil's coffee because I was working there at the time, and like when I finally got it to run and like produce the correct result with the JITted code, I just like did like a fist pump and let out one of those like yes, and
Nice.
I guess I had my headphones on and it was probably louder than I guessed because everyone just kind of turned and started laughing. So that's how the JIT came into existence.
Nice.
Wow.
Okay, so we're saying JIT, we're saying just-in-time compiler, and we're saying function pointers, and then just execute them, and so on and so on. But like, if there are listeners to our podcast for whatever reason who are like, JIT, never heard of that, can you explain this like I'm 5?
Yeah, so I'll explain it like you're a 5-year-old Python programmer.
Cool.
So basically, the reason that fast languages are fast is in large part because they are compiled down to machine code. So they're not interpreted like Python is. They run directly on the native hardware. So for a language like C, you can actually analyze the entire program statically and compile it ahead of time because you know, for example, the types of the data that you're working with, whether something's an integer, a floating point value, or a struct, or a pointer, or something else. With a language like Python or JavaScript, it's a lot harder because they're a lot more dynamic. So not only can you interact with the runtime by doing things like entering a debugger and changing values or inspecting the locals of a function, but like the basic types of your local variables and globals can change, and even like the set of globals can change. So it's very difficult to tell statically and almost impossible to prove statically that like something that should be an integer will always be an integer. And so what makes a lot more sense there is to actually let the program run for a little bit, sort of listen to the program as it's running. And once you've observed, for example, that you're adding 2 integers together at a given addition site, or 2 strings or whatever, then you can actually compile the program as if it was statically typed with 2 integers or 2 strings. And it's more general than that. For instance, if you're looking up a method on a class, at runtime, you actually have a pointer to that method, or you have a pointer to some class attribute or something else like that. And so basically we have this wealth of perfect information available at runtime that just doesn't exist ahead of time in a language like Python. So rather than compiling it ahead of time, we actually compile it just in time for execution. It's actually more like just too late because we let it run for a little bit and then we compile it, but it's just in time for the next time.
Right.
And so there's been a lot of success using this technique for languages like JavaScript.
I see.
PyPy is a great example of a JIT used for Python code, and it shows solid speed ups for a lot of different code patterns as well.
Well, maybe this question also serves as a good segue into the next one, but like it's not. There's no free meal here, right? Because like it's not just a matter of like, we just compile it and that takes 0 seconds. Like, I mean, normally the JIT compilers are like, big machines, and then you need to like start them up, right? And compiling that code and figuring out all this extra information normally it takes work. So like, yes, it will speed up your function, but sometimes the act of just like gathering all the information that you require to do it and actually do the compilation itself. It takes some time, right? So how are you dealing with this particular problem?
Yeah, so that's one of the huge benefits of this copy and patch compilation technique is that it's really, really fast to actually put together all the parts needed to actually build the machine code. So whereas a full-featured optimizing compiler, like I think we've all kind of waited for something to compile at some point, and it's not fun to wait, especially when you're actually like running your code. Like if every time you were running Python code you had like these several second pauses, like that would be no fun for anyone. And so the cool thing about copy and patch is basically that like it's right there in the name. The actual compilation step is very, very fast. Basically, there are precompiled templates of machine code, and we basically just lay those out one after the other and do some minor fix-ups. But for the most part, like the compiling itself is actually very, very fast. And so that's kind of one cool benefit of the approach. The main reason we chose copy and patch was for simplicity, because like it's also very easy to maintain for other reasons that we can get into later. But like that fast compile time and like low startup overhead is like a very, very kind of cool feature of the new JIT. Like just as like an implementation detail, we compile a loop after executing it, I think 16 times, which is a very low number.
Wow, it is, yes.
Yeah, it used to be 10,000 or something, right? Or like now it's...
Yeah, I think early on it was like 1,000 or something.
Okay, but now, secret question. Have you heard about the Vasa? VASA.
Vasa? No.
It was a ship. It was a ship basically commissioned in 1625, I think, by the Swedish king, Gustav something.
Yeah, I know
and,
the guy.
It was just like a...
Well, I'm so curious where this is going.
Yes. I mean, it's a famous talk if you have not seen it. Actually, I mean, I'm going to spoiler myself, but the reason I'm mentioning this thing is a famous talk by Scott Myers called "Why C++ Sails When the Vasa Sink."
Okay.
So this Vasa ship was basically like a Uber boat. It was like some shit, like enormous boat, like super armed, decorated, has 60 million gazillions cannon and things like that, and it just sank on the maiden voyage because it was so stupidly ginormous that it just went to shit.
Oh, and that never happened again in history, fortunately.
Yes, never. So Scott Meyer made this very famous talk called like "Why C++." I think it was the whole talk. Sorry for the introduction, but you just were so flabbergasted by the name of the ship that I had to explain.
I'm drawn in. I'm on the edge of my seat. Yeah.
He made this talk because like some person, I think Tom Cargill or something, like he complained about like C++ being insane. In particular, I think the sentence I have it here, it was like, if you think that C++ is not overly complicated, just what in the world is a protected, abstracted, virtual-based, pure, virtual, private destructor? so that is an actual thing. It's compliant. Anyway, so the question for you is like, okay, so the same way the talk say like, okay, why this is going to work now? So the question is like, we have a bunch of JIT compilers in the past for CPython. Actually, our good listener, Mark Shannon, hey Mark. So Mark has a GitHub repo, I think, called the JIT compiler graveyard or something like that, where he has this morbid list of like JIT compilers that have failed for CPython. So we have several of them. I think a non-exhaustive list is like the Unladen Swallow. We have the one that DeepMind made. What else? We have Pigeon. We have the thing that Pigeon was based on. How it was called?
It was called Pigeon. Yeah, Pigeon's gone through a couple different.
Pigeon 1 and Pigeon 2. So why this? Why do you think this now will sail? Why is now it's not going to sink in the ocean? Like why this JIT compiler will do it when all the others have failed?
Yeah, I think one of the reasons that we're kind of setting ourselves up for success with this new kind of JIT compilation strategy is because it's many of the same reasons why like the strategy seems so like approachable in the first place, and why I thought, this feels like something that I could just whip up fairly easily in pure Python code. The main kind of benefit that I see is that like we are able to lean on another compiler, in this case LLVM, to compile all of the stuff that we need ahead of time. So we can support lots of different architectures. We can compile lots of different code patterns without actually needing to have that in-depth knowledge of like instruction scheduling or register allocation or calling conventions or all these different things. And so the actual build step is mostly relying on other tools, and all of it is written in like pure Python itself. which makes it very, very approachable for outside contributors. It makes it easy to understand and maintain. And the actual JIT itself is written in C.
The legal language.
Sorry, we need to say.
Yeah, don't tell anyone. I think that the simplicity of implementation, and according to the paper and also according to sort of what we've seen in practice too, like you get good results for that extremely low level of sort of effort that needs to go into it to get something working well.
No, I think it's such a clever strategy here, because like one of the things that you get by free as well is this particularly important, is that you cover all the platforms that the underlying compiler is covering. So you don't need to write a JIT compiler for everything. Like even PyPy right now, if I recall correctly, they added support for AR64 very, very recently, right? Or something like that. Or someone actually contributed that, and it's an entire backend. So you will need to, like, it's a huge amount of work that you are skipping just by this. By the way, secret question, surprise question. Do you know what LLVM means?
So I believe it was originally an acronym for low-level virtual machine, but I think what I've heard is it is no longer an acronym. It's just the name of the project itself.
Exactly. Now it means nothing. It means LLVM.
It means LLVM.
Yes.
Good. The first L is LLVM and the rest is silent.
Right.
All right, so now we are in beta of 3.13, and people are going to get the JIT. That is an experimental JIT. You have to build your Python especially, you have to run your Python especially, and you said that even though there's this extra tracing and there's this extra compilation step and whatnot, like even at runtime, you have to actually do like compose those, like copy those pieces of machine code and patch them and whatever. Like it's equivalent essentially performance to the non-JITted code, which is impressive. But that's obviously not why we want this, and this is what you said in your talk at PyCon. So I want to know, what is the kind of roadmap for 3.14? What do you hope to achieve in the JIT there? Like, what are the first things that you're going to be trying out, and so on and so on? So how is the JIT going to become actually attractive in terms of performance?
Yeah, so right now, basically our main goal is making it faster, right? Like that's the entire reason why this thing exists. If we can't make Python faster, then like the JIT shouldn't exist at all. It definitely shouldn't be turned on by default, right? So we have some ways that we want to make Python faster using the JIT. And to clarify, when you turn on the JIT, Python isn't faster for most workloads, but when you're actually spending a lot of time in the JIT, it can be up to 20 to 25% faster. So it really depends how much time you're actually spending in JITted code and if you're jumping in and out of JITted code a lot. So in my PyCon talk that I just gave in Pittsburgh, I gave an example of like an iterative Fibonacci function. And so when the JIT compiler is enabled for like reasonably sized values, that Fibonacci function is like 20% faster. So there's kind of a couple different ways that we hope to like actually make the performance gains more meaningful for like actual workloads. The first one is spend more time in the JIT. And so currently, like we use the cool new perf functionality in CPython, where we can actually like profile.
Wow, perf functionality.
I don't know who added that, but
nice.
Basically, our team has collected basically performance profiles for CPython itself, and while running the benchmarks, and have kind of attributed different parts of the code to different portions of the runtime. So like for our benchmarks right now, when the JIT is not enabled, we're spending about a third of the runtime in the interpreter. And like for reference, we're spending about 10% in memory allocation, another 10% in garbage collection. So even if the interpreter were made infinitely faster, if it completed in no time at all, CPython would only get 1/3 faster, right?
I see.
Like your 2-second job would complete in your 3-second job would complete in 2 seconds.
Right.
And so kind of so that's sort of our baseline. Like when you turn on the JIT, those numbers shift, where we're now spending about 8% of our time in the JIT and like 25% of our time in the interpreter. So like a quarter of the time that used to be in the interpreter is now in the JIT. So we can get that number up just by spending more time in the JIT. So that means kind of finding more hot code, being able to support compiling more and more constructs, and being able to stitch that JITted code together so we don't have to jump in and out of it in order to kind of do control flow throughout the program.
So do you suspect like a weird future where sometimes to make things faster, we will actually also use the pure Python versions of standard libraries and not the C versions that are now only implemented to make things faster?
I think that's definitely like an option that we want to consider. So like take, for example, like, I don't know, like the any or the all function or the sum or something like that. Like, it may make sense just to be able to stay in JITted code and let the JIT compiler actually be able to reason about the entire state of the program and optimize things. It may make sense to actually use pure Python versions of those built-in functions or other library functionality. So like, as a very simple example, like typing.cast, which basically just returns one of its arguments. That's something where I don't know if it's currently written in C or not, but like
it was recently actually moved to C.
Yep.
It used to just be a Python function. Yeah.
Traditionally, you'd think like, oh, if we want to make that faster, then Python calls are slow. Let's like move that into C since it's such a simple function. But that's the sort of call that like the JIT compiler and like the optimizer that comes along with like the actual JIT backend, like that if we can see through that call, meaning if it's a Python to Python call, then we can actually just like remove the call entirely. And so that's like a simpler example, but like the more constructs that we're able to support and kind of the smarter that the JIT itself becomes,
Right.
Like it may actually make sense to start moving things from C into Python in certain cases.
I think it's also non-trivial, right? Because like you could say that because the JIT can have more information outside the function, it may be able to optimize something, or maybe the function is doing 3 checks for types and the JIT already has a gar or something like that. But like on the other hand, like normally C has access to low-level APIs that maybe like by double get item like raw, so the macro, right? You don't check for whatever it is. So it may be non-trivial to know. Like you probably need to benchmark, right? Like you need to check. Like,
well, but like to take your example, like if in C you would use pytuple get item, like there's nothing stopping us from doing the equivalent thing in the Python code once we know that like the item is an unboxed integer, maybe in some hypothetical future, and that the thing is a tuple, and actually just doing pytuple get item, and doing that in more places than you would think to.
Right. Maybe it's a light example, but like some of the low-level APIs or like some specific, like, you know, I get you. So there is some code around that doesn't even call the API. It just gets the struct members raw and does something weird or casting or whatever it is.
Right. I think there will always be a place for C extensions in Python and its ecosystem, but like I think a big part of our goal is to make turning Python code into C a less attractive option for like performance reasons, and even for people to consider basically turning C code back into Python where it makes sense. But yeah, like there will always be C extensions, and that'll always be like something that will make sense for certain cases.
All right. And so far, in the story that we know, like in the implementation you've done so far, give us a cool battle story. What was the most difficult thing that you implemented so far, or some weirdest bug that you discovered working on this so far?
Yeah, so I'll go with like a weirdest bug. Let's go. Basically, whenever we JIT some code, that is managed by a Python object called an executor. And so this is a normal reference counted Python object that has like a pointer to the JITted code and some information about it and other things. And part of the reason we have that executor is because we want to be able to remove JITted code if it's no longer valid. So an example of like invalidation of JITted code would be, let's say that the JITted code relies on some global variables. So like in many cases, we will assume that global variables are effectively constant and sort of treat those variables like constant. So if you're setting some string to the global name A and you're loading A several times in the body of a function, that basically just becomes loading the constant string because most globals are treated that way. But we still need to do the right thing if the globals are mutated. And so if the globals have been mutated, what we'll actually do is we will basically flip a bit on the executor that says you're no longer valid. So any JITted code that's currently in you needs to bail out, and we don't want to enter your JITted code again. And so that actually like removes the executor from the code object that it belongs to. So like the place where we would enter that executor in most cases. And so it decrements its reference count. And in some cases, it will free the executor. Mm-hmm. And there were weird cases in the JIT where like we would just get seg faults just randomly. And the problem is that when the executor, when its reference count drops to 0, it will, free the JITted memory just so that it can be reclaimed and we're not going to leak it.
Right.
But executors can jump from one executor to the other or call each other. And so there were weird cases where there was one executor on the call stack and there was no strong reference to it anymore after it had been invalidated. And so we were like freeing its code, mm-hmm. but then we wouldn't actually have the seg fault until we returned from several of the other executors and went back into that one.
Oh.
And so it's just memory management fun, but also when that memory management is the code that you're running. Because you can't even like step through it in a debugger.
Maybe in the back version you should run the GC after every function call or something, just to remove the executors.
Is it GC set threshold 1?
Yeah, a classic. It just makes everything 6 million times slower.
Right. So I have another trick question then. So you had those plans for what faster Python is going to do, and you had those plans for the JIT, and then PEP 703 happened. So did that complicate things for you? Did that make some of your plans like invalid? Like, how did you have to adapt the JIT?
Just for every other non-core developer in the call, PEP 703 is the PEP. Free threading.
Yeah, so I feel like we're kind of using the term JIT loosely, and that's probably like me to blame because I was the one who started using the term in this way. But like, when I tend to refer to the JIT, I'm referring to the new copy and patch thing that actually like compiles the machine code itself. There are many other parts of the JIT that aren't actually compiling machine code. So it could be like finding the code to optimize, like projecting those traces, optimizing those traces, and then feeding them into what I've been calling the JIT. And so free threading, it doesn't actually impact the machine code itself in any real significant way, or at least not that I've seen yet. So the JIT itself is, to my knowledge, completely thread safe. I actually haven't tested with both the JIT and free threading in like CI before the 3.13 beta release. And apparently one of the first things that people did upon that release was like, oh, I'm going to build a Python with the JIT and with the guild disabled. And it turns out that we were like missing one header file. But then that was very quickly fixed and it just works. So a lot of the optimizations and other things that kind of go into the front end of the JIT are probably not thread safe. In fact, they're certainly not thread safe.
Right.
And so I think that'll be something that'll need to be sort of reconciled and figured out. And when free threading is enabled, we also disable a lot of optimizations like respecialization and certain other things too.
Right.
But like in terms of the actual like machine code backend, to my knowledge, it's entirely thread safe, and so I don't think there are too many big issues there. I think the real kind of problems to solve are regarding like the profiling information that we collect, so specialization, which is self-modifying code, which is very much not thread safe.
Yeah.
And then also like basically creating and managing these executors and performing optimizations and other things in the in the face of multiple threads.
I think we also lost a battle there because the naming battle, because the Cinder term for those specialization, the profile information that you covered, I think it was called shadow code, which is like such a cool name that it now is lost.
That is really cool. And shadow frames.
The shadow frames is still recoverable. By the way, I just learned, but this is very interesting. I just learned that this is legitimately this is a very new advanced technique for profilers in C called shadow framing.
Well, I think we still have the opportunity to like name the JIT, right? Because all these JITs have cool like automotive names or something, like I'm kind of sad ours is just the JIT.
You have a cool name, right?
No, I don't.
No, you call it Justin, right? Like Justin.
Well, so that was the name of the branch. Yeah, Justin for just in time. But I don't think we're referring to our JIT as Justin. I've never used it Justin in conversation.
Justin the JIT.
Justin the JIT.
And I also heard like just some of this project. I'm not sure what the name was for, but it was legit.
Legit.
No, yes, that was one that was kind of floating around at PyCon. Was legit.
Yeah,
it's French for the jit.
Oh, legit. Oh. This is fantastic, man. We need to call it.
Don't tell
legit.
Eric Snow this.
Legit. Oh man, it's awesome. We just need Victor here to properly pronounce it. Legit.
Yeah.
Okay, there is two routes we can go here officially. Either we go the
We can call it
route-
shadow jit.
Exactly. So you fucking read my mind, Brandt. Like I love you, man. I love you. Yes. That was exactly what I was going to say. We have two routes here. Like one is like we go the metal route and we call it the shadow jit, or we go the jokey,
The elegant
the
way.
Cornel PY route. Yeah. We call it
Or like a Monty Python joke. There's probably something there. I don't know.
No. Legit. Okay, sorry. Too much fun. Cool. But one important thing is that in this time, basically everybody thinks, and this happens to all of us in some way or form, that this project is kind of a one-man job, right? Like it's only Brandt working on the JIT and that's it. Like he did it all. But as you know, like there is not anymore like this tale of the single cowboy developer that does everything is really like not true anymore, right? Like everything is a joint effort. So there is many people, I suppose, working with you on legit. So you want to tell us a bit like how people are helping you and like who are you working on, or if you're mentoring someone that works in the JIT, like how is that going?
Yeah, so before getting into like the JIT itself, like there's a bunch of people who have been working on like all that other stuff that I talked about, like the optimizers and things like that. So like in addition to my team, also Ken Jin, who I mentioned earlier, and other contributors like Saul Shanabrook. I'm not sure if I'm getting his last name right. It's my turn to pronounce someone's last name wrong. But he was working on some of the optimizer stuff at the sprint, and that was pretty cool too. So like there are lots of different areas besides just the JIT that kind of make up the JIT. And so even down to like making improvements to specializations, which keep happening to this day. But besides those people that have been working on sort of the optimizer and other parts of what we call the JIT, like there have been two people who have been stepping up and sort of saying, oh, I want to help maintain this thing too, and have been making some improvements there. So one of them is Diego Russo, who works at ARM. So my understanding is he's got a pretty cool job. He basically, on behalf of ARM, gets to work on Python ecosystem support. And as part of that, he's interested in helping work on the JIT as well. And so he's been doing some cool stuff there, especially around ARM support, but also like memory management and kind of low-level machine code stuff too, which it's always great to have that sort of knowledge on any sort of team. The other person is Savannah Ostrovsky, who has been helping out a lot with the JIT as well. So one of the kind of first improvements that she made to the JIT was actually upgrading the LLVM version from 17 to 18.
Nice.
And I feel so bad for this because...
That is not easy. It's not easy.
Yeah, I feel bad for this because I was thinking like, oh, it probably shouldn't be like too difficult. Like this is kind of like a good, like getting you up to speed. Like, you'll bump the version, then there'll be a couple kind of minor API breakages. But no, it was like insane. But it was crazy because there was all this sort of crazy stuff that needed to change. And she just sort of came up to me after she had done all the work and said, oh yeah, here were all the things I needed to change. It seemed like a lot more than you had mentioned. And I was like, whoa, like, yeah, but you were able to figure it out and everything. And so, and one huge part that like I attribute the sort of how approachable the new JIT is to like outside contributors is the fact that most of it is written in Python. And I know you had mentioned this when you were talking about the new PyREPL, how that the fact that it's written in Python is attractive to outside contributors because
Right.
like if someone sees something, it's a lot easier to kind of wrap your head around than just like approaching a giant C or C++ JIT compiler.
Right.
And so I thought that was really cool. But yeah, both Diego and Savannah have been super, super helpful with different areas of the JIT. And right now they're both working on things for like memory improvement and like garbage collection of cold traces and other cool things like that. So I like not being the only person who's maintaining this thing, and the fact that like other people are not only like stepping up to help, but are also just like doing a really good job of like creating work for themselves and like coming up with ideas and experimenting with different strategies and approaches is just awesome.
Right. I have found also that that's such an important moment for a contributor and a mentee when they are able to just, what you just said, like create work for themselves. Like at the beginning, like one of the more challenging things is finding areas to work with. So a good kind of moment to know that they are advancing or they have found like a good niche area where they feel quite successful is to be able to create this extra work or just to continue finding problems themselves. I mean, it's not that they need to do it, but it's certainly a check that they are actually advancing in the journey.
Yeah, well, and also just like having people who can review my PRs and
the real reason to get mentees.
Yeah, exactly. Like, hey, can you check out this PR? But no, seriously, it's like so great because first of all, like someone who didn't write the code, like I hope that the code is readable and understandable and maintainable, but like I'm also the one who wrote it. And so having people ask questions about the code makes it clear like what might want to be reorganized or what might we want to document better or add more comments for or whatever. And so I think that the review process is not only do they actually find like legit bugs in my code, but also just like being able to point out like it's a learning experience for both of us where I can figure out sort of the gaps in sort of the code that I wrote and how it may not be approachable in certain areas. But then also like anyone who's reviewing the code is also gaining knowledge about it and it goes back to how we were talking about like, reviewing 2 PRs a day or triaging 2 issues a day. If you're doing that, then you're actually learning a lot about the code. You're starting to see new issues before they're even reported. And that's sort of how you build this sort of knowledge about a project. And when that happens in a team environment, it's a really special thing.
Yeah, that's amazing. That we're getting people now that want to contribute because this is a feature that we've wanted to have for like literally decades.
Yeah.
And now you're saying it's actually mostly in Python. So the barrier of entry still high because you have to understand computers on a low level, right? But at least language-wise, okay, it's approachable. So that's amazing. So great job.
Well, I'm sure that you have learned. I mean, I'm sure because I think we talk about that. But you have learned quite a lot of like low level.
Oh yeah,
like ELF.
I think I've read every blog post on the internet about linkers and loaders. There's a lot of really high quality blog posts about linkers and loaders, but
secret question because you're talking with the person who as you know, I pride myself to being a linker connoisseur. Like my Python bash search attracts linker problems, and it's true. At work, I'm constantly fixing these things. So prove yourself, Brandt.
Oh no,
prove yourself if you really are a linker connoisseur. So you probably know about the BSS section in an ELF executable, right?
Yes.
What is the BSS section? That is not the question. It's just a pre-question.
The BSS section is zeroed static data. So it's basically data that is not present in the executable. I think it only has a size, and basically when it's loaded, that size is allocated probably lazily, and it's initialized to 0.
Correct. Okay, now the actual question. What does BSS stand for?
The bullshit section.
What?
That was my guess.
The bullshit section. Oh man.
I'm actually not sure. Wait, let me try to.
Can you try to guess? I mean, I would be very surprised if you.
I can try. I don't know. What is it?
It stands for
block starting symbol.
It's such a bullshit name. It could be perfectly called the bullshit section. So it stands for block starting symbol, and it's basically like the reason it's called like that is because it used to be a pseudo operation in an old fucking AVM operative system, and the idea is that they use this hack when they create like a symbol that is called like bullshit or whatever it is, and they use that symbol to say we are going to put here a bunch of shit. So symbols normally have a size, like the size of this variable is 10. So they say, well, I don't know, 6 million, and they call it the bullshit symbol. So they call that block of data block started by symbol or block starting symbol. And in some places it used to be which you don't see it anymore, the BES, the block ended by symbol, which is the end of the BSS section that now is not there.
But now, since we're well over an hour, I would like to move to our regular programming, which is But now I'm thinking, actually, if we're efficient as hosts, we should actually get the guest to do all the work. So how about we don't do the PR of the week, but we get to have the guest suggest a PR of the week. Brandt, could you?
Oh no, I'm not prepared. This is a surprise.
Wow.
Just off the top of my head, probably PR 120250 by Diego Russo. So this is a cool one. I think it does a good job of showing sort of how approachable the JIT build scripts are, the pure Python code. It's like maybe a 20-line PR, and it's called Reuse Trampolines on ARC64. And so basically, in the JIT code, occasionally, actually quite often, we need to call out to Python API functions or just library functions. So like if we need to, deallocate something, we call pydealloc. And so the problem is that when we are actually allocating the JIT code, we don't really know how far away we are from the main executable and where its symbols lie. Mm-hmm. And so we use long jumps for those. But actually on ARM, the longest direct branch is only 28 bits.
Mm-hmm. 28 bits?
Yes. Because everything is a fixed size instruction.
Wait. But that's stupid. That's stupid because fucking ARM has this ginormous fucking code model. Like it's just enormous, no? Like I'm just making this up.
So there are register indirect branches, so you can load a value into a register and then jump to that.
Right.
But actually jumping to a address that is inside of basically all inside, it's the immediate value of a single instruction. The furthest that you can jump is 28 bits, 28 signed bits. And it's encoded in 26 signed bits because everything is 4-byte aligned, right? And so while technically you could have a single instruction, have a series of instructions that basically builds this value or loads it and then jumps to it, because we're not actually the ones generating the code, LLVM, for whatever reasons it has, chooses to emit these 28-bit jumps every time that we call a Python API function. And so what we actually have to do to guarantee that we can jump to that symbol that may be out of range is we compile a trampoline for that function, and we jump to the trampoline, and the trampoline is just a snippet of code that we write that basically just does that register indirect jump that's guaranteed to be within range.
Right.
And so the original code that I wrote for this had a bug. Well, not a bug, just a inefficiency in that if the same bytecode instruction made several calls to the same API function, it would emit one trampoline per call, not one trampoline per symbol. Mm-hmm. So if you called pydealloc 2 times, it would emit 2 trampolines, and it would jump to them separately. Right. And so basically what Diego's PR does is it deduplicates these trampolines and basically says, okay, if we already have a trampoline for one of these functions, then just use that one instead of emitting a new one. So it's lower memory because you're not emitting all these extra trampolines, and it's probably a little snappier too. It was there are some sorts of changes where we could run the benchmarks, but it's clearly a win because we're just emitting less code than we were before to do the exact same thing.
The best way to be faster.
Yes. So that's an exciting thing to see.
Right. Impressive.
So I mentioned that we have one of these trampolines now per bytecode instruction. So if I have a single bytecode instruction that calls pydealloc, we'll only have one of those trampolines for every time that bytecode instruction is emitted. Kind of the next step will be making it so that if several bytecode instructions all call that same function, that we only emit one maybe per trace, or have one of these trampolines be shared by several pieces of JIT code. Because that's almost a larger inefficiency, that if you have 50 of these instructions in a trace or somewhere in memory, you're actually duplicating the same trampoline 50 times.
Right.
And so I think that'll be kind of a good next step that kind of builds naturally on this one.
I'm also working with Diego Russo on a bunch of things that are totally unrelated to the JET, but there's been a bunch of work we did on speedpython.org, and now we're working on getting the so far beta and closed and paid ARM runners on our GitHub CI to work, which is a little complicated due to billing and whatever, but we're working on that, and so on and so on. So like a surprise, very active contributor from ARM, which is amazing to see. So hi, Diego. And now let's find out what was already being done in the past 2 weeks. What's
going on
in CPython?
Please note that we are now in 3.13 beta, which means it's a version that is under the feature freeze. So when you are hearing about new features today, those will be landing in Python 3.14, the PyPython, in October 2025. With this disclaimer out of the way, let me talk about PEP 649. Jelle is now implementing that in full swing. I already mentioned he even created another PEP 749 that closes some of the gaps in the original PEP and actually provides a nice road to implementing and adopting the new change. So now Jelle landed the compiler changes needed for creation of the dunder annotate function. So that's already landed.
Cool. So another thing that happened is that Petr Victorin created this incredible PR, not easy at all. It's 2,000, the patch is basically 2,500 lines added, 1,000 lines removed of PR, where he documented how string interning works. And basically the process to clean up all the behavior, because there was a bunch of inconsistencies regarding the actual lifetime of string interning. And especially since we have now this concept of immortal objects, and when you tear down Python and bring it up on subinterpreters, so the whole thing was a bit ill-defined. So he could basically clean up all the behavior to make it possible for interstick to be actually immortal. So when you tear down Python and then you start it again, like Blender does, for instance, then you don't leak memory, which is quite important. And this was not an easy task, so shout out to Petr for putting the work on that. And he added, I think, a bunch of extra new, private APIs for this with all these funky names like PyStream mortal, but not mortal, but really mortal or something like that, just to clarify which one every piece of code is doing. So much better, more readable, and less bugs.
Yeah, pretty cool. Speaking of new contributors, an external contributor, Ruben Vorderman, improved the speed of str.count, so the count method on strings, and the count method on bytes, and the count method on byte arrays, twofold, for counting single characters. So that's a pretty cool pointed optimization that fixes a relatively common case, honestly. So great job on that. So Brandt, do you have any PR that you can comment on?
Oh, let me think. Off the top of my head, PR 120344 by Ken Jin. So this one's currently open, under review, but it looks really, really cool. Basically, the idea is to constant fold attribute loads in the JIT. And so sort of like how I mentioned before that we turn global names into constants speculatively, the same idea goes here for attributes of classes. So, for example, if you're looking up a member of an enum, the idea is that that would basically just be loaded as a constant in the JIT code. And so this is cool because it opens the door to other things, like, for example, maybe doing the same thing with methods. But it's also neat because it builds on some work by Saul, who I mentioned earlier, who was working on stuff with the PyCon sprint. He made some changes to the optimizer during the sprint that allowed us to basically reason about types more effectively. And so this is something that wouldn't have been possible before that change, but now we're able to. So that's kind of cool to see sort of how those sort of different changes are able to build on each other and make new things possible too.
Awesome. some interesting changes that happen on the datetime module. So the first PR that we have here is that, man, I always struggle on reading this, so I'm going to just take 1 second to properly pronounce the, so neonene, which is neonene. So this is actually even funnier in Spanish because nene means, it's like cute for child, like nene is like, you will say to like, I don't know, it's kind of weird. So neonene is like the new child.
The new cute?
Yeah, the new cute child. It sounds weird. Okay, neonene. So he added basically support for additional checks to the and to ensure that the datetime module works with subinterpreter. This is true because like the datetime module has some super weird like C API. It has its own bespoke set of stuff. Like it's very complicated to describe it here, but there is like dictionaries for the API. It's kind of weird. So it was quite. And it's still quite complicated to port to make it work with subinterpreters due to how the whole structure works compared with other modules. So this is working on that particular direction. And regarding this, another change that also happened in the datetime module is that Eric Snow fixed a crash in the datetime module around the finalization of the module static types. This is quite interesting because I think initially to ensure that all the types that the datetime module creates were properly clean, he used an attexit, then the private version, right? The underscore attexit like thing, but there is some race condition between the two. Because like they were referencing classes that maybe like already been nuked by the GC. So I find it very cool how we are doing this now. So obviously we are trying to make it work with some interpreters. We don't want static types because those are like built into the binary and there is only one and blah, blah, blah. But you need some kind of like static type here that is not just linked to the finalization moment and that all those things are alive when you need them. So he basically added, I think in the runtime state or something like that, like an array of static types. So it's like static types, but in the runtime, structure. So he can like walk that array and like delete them in topological order, I suppose. So yeah, quite cool. Nice.
All right. So this is not landed just yet, but it's just about where Python 3.14 will default to Pickle Protocol 5. That was originally implemented for Python 3.8 and described in PEP 574 by Antoine Petr. So the reason why this protocol exists is that Pickle should be usable in a way where large data is handled as a separate stream of zero-copy buffers, letting the application handle those buffers optimally, which is super useful for data libraries like Dask, PyArrow, PyREPL, and so on. So whenever you have such large data where serializing it and copying that memory is just a huge waste, and you could use zero-copy buffers instead, this is going to be a big win. So the switch to Protocol 5 by default isn't done yet, as I said, but external contributor Benedict Tran noticed that the pure Python implementation of that is not exactly in sync with the C implementation of Protocol 5. So he already fixed one issue with the compatibility between the two, and hopefully identifying that was the one blocker. The already open PR to switch to Protocol 5 is going to happen for Python 3.14. And when that happens, we will be able to implement some optimizations for multiprocessing. That depends on pickling for communicating between the main process and the worker processes.
Okay, Brandt, do you know who is Tian Gao? Do you know who is this person? Who is this person?
Yes, one of our newest core developers.
That's true.
And PDB maintainer.
Wow, new core developer. Who promoted it?
Who
Yes, Brandt promoted.
let the record show who supports getting rid of the jump command. PDB,
All right.
I think.
But do you know that Tian Gao has a YouTube channel?
Yes, I had heard that. I've never seen it though.
Yeah, it's in I don't know the language actually. It's certainly not English. I'm not going to make a guess, but like it's not English, so I don't know exactly what's going on. I heard Python from time to time, and obviously it's about CPython, but like, yeah, that's cool.
So you've watched the videos?
Just one or two. I mean, there is a video when he talks about being a core developer, clearly, but like he seems happy, so I don't think he's just.
That's good.
I'm happy with the thing, but yeah, I don't know what the videos say. So, but I learned recently that he has a YouTube channel. Someone who watches that channel pointed it out to me.
Yeah, very cool. I never knew.
Okay, so this is Tian Gao, which is focusing on the debugger like PDB, apart from other work. So he made 3 PRs to improve the PDB user experience. In particular, for example, now the stack entry is printed whenever the user input is needed. So when you need to actually put something, we saw the stack now, which is it provides basically a much better experience when you just jump into the backend. You need to say something and then you know where you are. So the small things regarding UX have been proven to be quite big changes for users. So I'm very glad that he's working on this, and he has, as we mentioned in the podcast, many other changes in the pipeline to improve PDB. So nice, Tian.
Right. So now it's time for my scheduled programming of free threading changes. So let me go through all those quickly.
You need some music like Benny Hill or something.
Yeah, we almost need like a specific section for just that. But yeah, like all of those were backported through to 3.13. So first of all, Sam Gross made PyMutex public for non-limited C API, which I find really cool because C extension authors will want some locking now that they cannot depend on the GIL. And PyMutex seems to be both easy to use as an API because you don't have to do any double locking because it already frees the GIL and everything for you. And it's also pretty efficient. And in fact, Sam wrote an excellent how-to for free threaded C API extensions. So if you're wondering like, how do I even write an extension that will actually make use of free threading, you can go to docs.python.org/313/how-to, and then in the advanced development section, you will find C API extension support for free threading. So try it out, read it, try to implement some simple extension, and give us some feedback on what is missing, what did you not understand, or what not.
This is very important because if you are a C extension developer, you will probably need to read this in the future. So just read now and save you some pain before we are supposed to have all the answers. But wait a second, Gukas. You talk about PyMutex, Gukas, like you know your shit. But surprise question: do you know what PyMutex is really? What is PyMutex? Okay, yes, a mutex, whatever. But if you go to the C code and it will be extract PyMutex, what is really PyMutex?
It's I don't remember like the size of it, but it's like an int.
It's an int. Oh, okay.
Yeah,
So
like
you know your shit.
I looked at it, but like so it's some int. Yeah.
It's an unsigned integer of 8 bytes.
No, 8 bits, not 8 bytes.
It's uint bits. Sorry, yeah. It's a uint 8 t.
Oh, it's a character. And it's set to w. No, because that doesn't actually fit in ASCII, so no.
Oh, very good. Very good.
Can we continue?
Yes, we can continue.
Let's continue then.
Pedantic Pablo.
Right, we already talked about Kenjin. So Kenjin made py_type and py_set type thread safe. That's amazing. And made pytype has feature atomic. And fix some races in instrumentation.c. So he's like, just making things better for free threading all around, which I love. Daniela Parmigiani, who we invited to the Language Summit, fixed TSAN reported races in PyMemberGet, PyMemberSet for the PyTObject EX type. So that's also great to see. And again, Kenjin, who we mentioned just a second ago, fixed a crash when 2 threads modify and access Dunder class of the same object at the same time. So it's one of those
I'm going to say that if you're doing that, you deserve what's coming, right?
Yep.
Right.
You deserve it.
There were discussions at the time where we were doing static typing, like at the first time, I was like, does anybody even do this? And then every change in Python, this comes up somehow. Like, oh yeah, what if you actually modify Dunder class? So it comes up so often. In any case, those are the most significant free threading changes this time around.
Right. And then we have our very good friend Victor Stiner is our friend, so we can do the job. So Victor added an efficient public API called PyUnicodeWriter to create a Python string object from the API. Actually, he didn't really add it. He basically exposed it because this has been around in the CPython forever. And he has basically moved all the internal usage of basically having to create these things. And I know it because the parser uses quite a lot. It was quite cool to use, very efficient. So now I'm very glad that this is exposed. So very good, Victor.
Very cool. So now the changes that you were all waiting for. So like yes, exactly. What about the pink is the new black? So let me start with something easy. PyREPL used to be a little careless about exposing its internal state in the globals of the activated interpreter. When you started PyREPL and you were actually listing globals, you would see a bunch of our global variables from the underscore PyREPL module. So that's no longer the case.
Yeah, some of them could count as a feature because you don't need to import OS or sys anymore. It was just there. But like then there is this mysterious can use PyREPL. Yeah, but one cool thing, and I'm very, very proud of this. So I have the best coworker on the planet. I don't think he actually listens to the stupid podcast. Even if we talk about podcasts all the time. We like horror podcasts and we talk about it, but he doesn't listen to this podcast, man.
He already knows everything from your descriptions.
So the best coworker is Matt Wozniacki. This guy is just fantastic. I love this guy. Is fantastic. Like he's the best developer on the planet. And when I need to explain to someone like why he's really good, because like everybody has learned like cool stories about incredible developers. But every developer is good in different ways. So when I explain how Matt is good, it's like Matt is the person who always put while loops around reads. You know why? Well, many listeners probably are not that good as a developer, and I will tell you why. Because in C,
the legal language.
So in C, when you call read, it can return a partial read because like shit happens. So you tell like I want 30 fucking bytes of information, and he said, well, here is 10. So you need to continue reading until you get enough bytes. That's what the fucking read says. So you need to while loop around the read call. Most of the time it will not happen, but you need to do it. So Matt always put while loops. Like fantastic. Okay. Anyway, so I nerd snipe him quite hard. Because we have, as you know, in previous PyREPL episodes, people really like to paste the entire text of Frankenstein in the REPL. This has been a big feature request. So they like to paste Frankenstein, and we have this ON square algorithm that not both. Even if we are still faster than PyPy with its decompiler, but now we really wanted to be super snappy. So I nerd sniped him into fixing this, and he did. He did very, very good. Like he read the whole thing and implemented like some heavy caching around. And very good. So now you can actually paste Frankenstein in the REPL, and it's as fast as the C version. So very, very impressive.
We're focusing on the most important features that people use all the time.
And clearly this is pointing at like a user need that's not being addressed, right? Like what if we just add Dunder Frankenstein as like a built-in or like a global? So that way you don't need to paste it. It's just always there, right?
It's
when you need it.
always there.
Like man, I'm not serious. I need to be a serious person. I'm in the str.count. I will not add Easter eggs in beta free section. Like I will not do it. Maybe we should do it. Like can we compress the text?
I will not do it. Oh, maybe we should.
Only on debug builds, right?
Okay, but to be honest,
it's a build option.
I've been told that we should be responsible here now that we have a huge audience. Okay, so we are not making fun of this. We are half making fun of it, but the real reason apparently is because this was a request by Trey, I think Trey Hunter.
Yes, Trey
so he's an educator and like he deals with people learning Python quite a lot. And what happens a lot is that people just paste a huge amount of text for whatever reason because they want to paste it as a string and then call a split on it and things like that because they don't want to teach open files yet or whatever it is. And what happens is that they paste something that they were not expecting and now it's fucking huge. And when you press Ctrl+C, it takes a while. It takes a while on anything, by the way. Like if you do it in the shell or like in Beam, like it's too big. Like there is some races on the terminal and whatnot, so it's very annoying. And what was happening in the REPL before is because we didn't have signals properly baked in and it was very slow. You need to wait until it pastes everything and it takes like minutes. So it was a really bad experience And even if you wait for it, like a very long test, it was taking a lot. So Frankenstein was obviously not the objective. It was just a benchmark for pasting quite a lot in the REPL. I learned quite a cool amount of things testing this PR. For instance, I learned that if you're using iterm in macOS, there is a fucking feature, and I kid you not, this is real fast pace.
Yeah.
So you go to iterm and then you click edit paste special. There is two cool options called paste faster.
So wait, is it spelled fast paced or fast paced?
No, it's called paste faster. So it's
Okay.
just do it faster.
It's a fast paced paste.
Yes, it has a non-trivial effect. You cannot predict what will happen. So what it will do is that basically it has the paste buffer and it will copy it faster. So it will not introduce delay. But you need the consumer to consume fast enough, because otherwise it's not going to do it. So depending on like the buffer and the consumer buffer and the OS, you will actually do it faster or not. So it's unclear what will happen. But yes, I learned about that feature. Now
That's why you got to put while loops around your read calls, is in case the buffer isn't ready yet, right?
Very important. Don't do this in Python. It's unnecessary. But
Right. But you can even see the data rate when you're pasting.
Yeah.
You can literally see bytes per second.
Yes, this actually break a feature that Gukas wanted. And I'm going to reveal it here, Gukas. So Gukas was in love with the fact that because it was super slow to paste text in the REPL, like it was appearing like you are typing it. So it has this nice typewriter like effect, or like it looks like it was like appearing. So instead of simulating it, Gukas is like, no. The fact that this is slow is a feature, because like it has this effect.
It looks like you're typing.
Yeah, except that it looks like the person typing broke their fingers when they go to line 2000 because they went square algorithm. So it looked like he's getting tired of typing.
And slower and
You're just getting tired, yeah.
Yeah, we don't pay them enough, so it was too slow. But anyway,
but for small paste that was nice, because it's like all this animation that you have on your phone and everywhere else. Like a little bit of movement explains what is happening, right? So instead of there's just like a new content flashing at you, you could see like, oh, this is why it appeared like this.
Yeah, but not what you are pasting Frankenstein. Well, anyway, this PR was not easy. So it was quite tricky. You needed to cache quite a lot of stuff around it. So thanks, Matt from Bloomberg.
All right. Yeah, there were a bunch of other changes. Like Lisandro's fixed namespacing of completions, and Pablo fixed and already forgot that he made Python respect Python basic REPL, the environment variable, when running the interactive inspect mode.
Well, I didn't forget. It's good that I made that, because like otherwise you will always get the new REPL and it was broken. So now you can run it without being broken with the old one.
Okay, but the new one still needs to be fixed, is what you're saying.
Right.
Okay, cool. Yeah, so Brandt asked like what -i is. So I
You
take
don't know
it you
it?
don't know. You're not a user of that.
I don't know. I'm new to this whole Python thing. I don't know.
Oh
what
wow.
dash I
Okay.
does.
So that's like says activate the JIT. That's what it says. you need to pass a JIT file. It needs to be written in Python. So a .py file, and it will activate it.
No, it's actually Python inspect, which allows you to like look at things like after the module has been executed, or -c, or the script that you passed it and whatnot, which is usually useless, but sometimes
No. What do you mean? No, man. It's
because that's after.
Is that the thing where it like launches a REPL after your script has completed?
Yeah.
Yes.
It executes the file. Man, it's fucking. What do you mean useless? Like who are you, man? Like no.
No, like-
you have a fucking like random file with functions, and then you call Python -i, and now you can like play with those functions. It's kind of cool. Like you paste fucking code from the internet, like 6 million implementations of like the JIT compiler if you want, and then you spawn a REPL with all those, and you can play with them. It's not useless, man.
I think I have used that before too, because if I remember correctly, like if you're running some script and it raises an exception and you have -i, it will enter
Yes.
like a REPL
Yes.
with the exception, and so you can do some debugging
Yeah,
there.
you can look at globals and stuff.
What do
Yeah,
you mean,
that's-
man? Gukas, you're such a jokester. What do you mean is useless? You
No,
are
because, like,
useless.
for a regular execution of a regular program that has like an if main section, like it does nothing. But like, yeah, if
But
you have
that
just a
is
bunch of
cool,
functions-
because like if you have like, again, example, if you have like a module or something, right, and it has the if main and then it does something, and you don't want that shit to happen, and you just want the functions because you want to do something else, then you can run with -i and it will not call the thing.
It doesn't set the main module's name to main?
I don't think
If you do
so.
that?
I don't think so.
I
No
think
way.
it does.
No,
I think
it'd
it
still
does.
be main.
I think
Okay,
it still
what-
executes.
Let's check.
What I'm curious is what happens if you just type Python-I? Will it do a REPL, and then when you exit that REPL, it'll start a new one?
Southern REPL. No, I think it's just gonna be a one.
No,
REPL.
it wants the argument, right?
Let's see.
I'm checking the other thing.
Yeah, no, it just starts one single REPL.
And when you exit that, it'll just be done,
Yeah, it's just done. Yeah, I just tested that right now.
even with the new REPL.
Even you're asking hard questions. Yes, even with the new REPL.
Yeah. Well, obviously, I check by the way, and obviously, if you have if name equals main, it does it. So, but yeah. So yes. All true.
Useless. Right. So we are in agreement. Awesome. Okay, cool.
yeah.
Right. So in any case, we still have almost 20 open issues.
20
specific
open
to
issues.
PyREPL. If you just look topic REPL, it's going to be like 38. But like if you look at them, like most of them are from before May, which means they're just tagged as topic REPL, but they're not our issues. They're previous issues. So
Lucas, I just want to implement new features, not fix bugs. So what can I do?
Well, Book is not going to answer because he's busy doing storm stuff, like he's running from the storms or something. So I will answer to that topic, anonymous person. So it turns out that some of the things that the new REPL doesn't do basically makes it not have enough like feature parity. So you could call those bugs. What about that? So you can half implement like a feature if you want. So you can still do cool things that you can show your friends in the sprints. So just come to the sprints and help us bring the new REPL to speed compared to the old REPL.
right, especially that there are sprints coming at EuroPython.
It's easier than you think, too, because at the PyCon sprints, I said, hey, Pablo, it would be cool if there was a clear command for the REPL. And 20 minutes later, he was like, all right, there's a PR open.
Yes. I want to say something as well. Like, so yes, there is actually this is fantastic. There is a clear command if working, well, actually, so okay, two things. Sorry, this is interesting. So that PR was not as easy as I thought. It was 20 minutes, but it was, as you know, you saw me. It was a bit challenging because the clear command, like, so the REPL loop works in a way that you enter this REPL world and you say like, get me the string. And what Python wants is basically what you just type. So you type 1 + 1, it will be the string 1 + 1, and if you type a function, it will be the text of the function, right? And it will grab that text and it will pass it to compile and it will create the call object or whatever. But then when you are in the REPL world, then this new fantastic planet when you can like do this multi-line editing and like all this bullshit happens. But at the end, it's just give me the string, man, the string. So when you exit that function, it's just a string and the world is closed and everybody goes home. So the clear function only happens when you are in that planet. But the commands in the REPL like exit or help or all of that are implemented parsing that string. So when you give me the string, if it says just exit, then we interpret that as a command and then we exit or whatever it is, right? But clear is tricky because clear is something that needs to happen in the world, like in the new, super cool thing. So it was quite easy too hard to implement because we needed to like schedule the clear or something like that. So basically we take clear, we schedule the command, and then we go back in and then we clear the command on entry because otherwise doing it from the outside, you need to initialize the terminal for the clear to happen. But yes, clear is a thing now. You can type clear and it clears the command. That's awesome. But, and I wanted to say this very clear. I just surprised myself of how cool that was. So we have to ask permission to the release manager, Thomas Wouters, because obviously that was a new feature. It's not a half feature bug that blah, 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 blah. So we are responsible people and we ask. And Thomas said yes. So now you can type clear as Brandt envisioned.
Although one kind of funky thing about the clear command is you can't call it like the other ones. So like before we had this thing where you have to call something, and if you don't, it would say like type call help to enter help or type quit to quit. But now we have like the opposite situation where just typing clear works, but if you call clear, it doesn't. So I think we need a clear built in, Pablo, and then it'll be perfect.
No, but can you imagine that someone has a function in the Python RC or whatever it is, and it's called clear, and it does some other bullshit, and now we override that? Like, no.
It's in built-ins.
Well, clear.
It would be like, yeah, like this is what Brandt is suggesting.
Yeah.
No, yeah, exactly. But like now, imagine that someone like has a function called clear that they have in their Python.
I get it. You can't do it. You're just not capable, right?
No.
It is virtually impossible. It is like, it's physically, he has proof for this, like mathematical proof that this is just not doable in this universe.
Yeah, Pablo can't do it. Yeah. I had a hunch he couldn't do it.
You know how the exit is done, right, Brandt? So we inject in built-ins an instance of quitter. And there is two instances of class quitter, that is exit and quit. And like, so I cannot wait to implement class clearer and has an instance of class clearer. And when you type clear, it says like, no, you meant to say clear call. And like, you need to
Call clear to clear.
Clear call. And then we will
So
intercept.
when you want to clear the screen, it's instead just putting more junk on your
Exactly.
screen.
But you know what? It will be even cooler. You know.
Wait, what if
that
we
is
make
just
the
a-
repper just
yes.
like 10,000 characters of space?
Frankenstein.
That's the Frankenstein.
Clear shot, please, fucking Frankenstein. Man, I want underscore Frankenstein underscore. Man, we should really do this.
You can make it like a compile, like behind like a preprocessor macro.
Is Frankenstein open domain now? Like is that like or is it
It's
copy-
probably Apache licensed or whatever the PSF
we
license
can
is.
compress it like almost making it sound like the exit like the some of this weird like text file with malware inside. We can compress Frankenstein, call it Frankenstein.will or something like that. Like we put it with setup tools and pip, and then we uncompress it when you type.
And it's then a functionality called ensure Frankenstein.
Yes, ensure
Ensure
Frankenstein.
Frank.
And then you can pass that as local, install it in your local directory. But you know something like, man, I was thinking that maybe we should. I learned that we have the power to intercept every single key press using the new REPL. So Control C, for instance, it was not working. We intercepted Control C, so we can intercept anything. To be honest, so we can intercept Control L, which normally is used to clear the terminal. I use it all the time in Bash or my cell or whatever it is, and then we can intercept it, and then we can print to the user. No, you clearly wanted to say clear parentheses close parentheses.
So it's the opposite of the others.
Yeah, exactly. Yeah, to make people and Control D, that's an exit. Now we said like, oh, you clearly wanted to say exit parentheses.
I'm thinking we should just have it be when you call the clear built in, it just says type clear to clear.
Exactly. Yeah. and then we paste it very slowly, like one character every half a second.
Oh, it's a feature.
It's a feature. Oh man, like Jesus. Well, anyway, so yes, clear. You can implement. Okay, if you don't want to help us fix all these bugs, which you clearly want to do, this is like successful people do this every morning. It's their morning routine. They wake up and in their contribution time, you heard it in this episode. Like, if you want to be successful at CPYTHON, grab your cereal and fix some PyREPL shit. That's how you get. That's how you get successful at CPYTHON. Or you can implement new commands. What can be the next thing, right? Like we have exit, clear, help. What is the next thing? Frankenstein, maybe.
The next thing is syntax highlighting. That's gonna be a big one.
Yeah,
for
I cannot wait
314.
for that to be
Yeah, I
another
also
ON
can't
square
wait.
algorithm.
Yeah,
you
that's
know
gonna
that
be
is
fun.
ON square, right? Because every single
Yes.
character you need to highlight the whole thing.
Yeah.
We need a JIT for that, man.
And
like
also
that.
we need a parser that is recoverable, right? Because otherwise you're gonna have like flickering of colors, right? When you didn't finish yet writing the if statement or whatever.
No.
Because
Why
you have
you want a
multi-line
parser? No, it's a tokenizer, right? You don't want the parser.
So okay, but like if you don't want a parser, like how are we gonna do like match statements with just a tokenizer?
Match statements, whatever, man. You just match is match. If you add match is match. Match is match. Match is always a match
We're
statement.
gonna assign that to Brandt.
Oh, yeah, I'll take that.
I mean,
one.
we can say like match equals or something like that, but like match equals we can undo it, but like no, match is a red or whatever it is,
You
the
know-
color of match.
We can make it faster though, because we do JIT the REPL. Because we have like a debugging mode where it can see what we're JITting when we JIT, and if you start up the REPL, we JIT like 10 or 20 traces. It's pretty
Yes,
cool.
actually, that the REPL will be now the first thing that crashes when you fuck up the JIT, right? Yep. Nice.
No, Bootstrap Python is a whole other.
Yes, the classic, like the classic Bootstrap Python.
Which has a JIT, by the way. On JIT builds, Bootstrap Python is JITted, which is kind of
Oh, really?
yeah, it's
Nice.
easier than making it not, I guess.
Right, Jesus. Well, I can implement yet another parser. Don't worry, Lucas. I have the technology. we can build it.
We like parsers, I think.
So we like that. You know that was the name of the org you used to create the new parsers.
Is there a we like rebels?
No. Nobody likes rebels.
Nobody likes rebels. That's the new name of the organization.
Nobody likes rebels.
But yeah, syntax highlighting is going to be cool. I think it's nice. I mean, we can also we don't need to do this. Like, are we going to bootstrap the whole syntax highlighter? No, we're going to steal it, right? Like we just vendor pigments or whatever it is. Well, for another time. Like you have not heard anything. People.
Ensure pigments.
No.
Yeah, exactly. For now, like let's hope that we're gonna get some contributions and maybe we're gonna be able to fix some stuff ourselves at the EuroPython sprints. Now there's almost 20 open issues open for PyREPL, and after we're successful, I hope to bring this number down so that the open issues is no more than 20. So that's going to be amazing. Because usually what's happening is like for every issue that we close, we open another one because, you know, we identified some other edge case. So hopefully we're actually going to bring the number down.
By the way, since PyREPL is private, like the module is called _PyREPL. So since it's private, we can rename it post beta, whatever. Can we rename PyREPL to Le REPL? Le REPL.
I don't know. Maybe that actually means like some small child in French. I don't know actually. So
okay, we will ask Victor Stinner about it, but yeah, Le REPL and legit.
No, it sounds like adorable.
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 Adorable. Well, anyway, now I really want to try to paste Frankenstein with the JIT enable. Like I really want to try it. It's a loop. It's a whole loop. It's a super whole loop.
Yeah, you can see if it's any faster.
Wow, man! Like the feature is here. All this like fuck AI, man. Like the JIT compiler. This is what we need. Paste Frankenstein.
Yeah, we're gonna let you know for the next episode if it's any faster.
Oh no! All right,
man. Just to see. Okay. Let me show you this. It's very difficult to show. Like Lucas, make sure to not cut this. So it's very difficult to show this on like obviously a podcast. But I have. Yes, audio. But I have the perfect example. So don't cut this silent. So this is how much time does it take to paste Frankenstein with the after all of the optimizations that we did, but before the PR that Matt Wodnicki made. So I'm going to paste it. I'm going to do this sound, and then I'm going to do it again when it finishes pasting. So check this out.
you should make this longer in post.
So that's it. That's how much it took. Okay, now this is how much it takes without any paste faster item shenanigans, just the default with the after the optimization. Okay, are you ready? Wow.
Nice.
Very cool.
Thank you for being with us, Brandt. 2 hours. I hope that our joke level has been acceptable.
It was a great 2 hours.
Awesome. Thank you very much, man. Like we should repeat this for sure.
All right. And for us, we're going to resume in 2 weeks with letting you know whether the JIT helped for the REPL and some other fun topics.
Right.
So see you next time.
See you next time.